equals 8. 34 divided by 2 equals 17. That is 8, 17, which means we're looking at an 8, 15, 17 triangle, which means I just need to multiply each of those numbers by 2. 8 times 2 is 16. 17 times 2 is 34. 15 times 2 is 30. Your correct answer is 30. And if you didn't remember Pythagorean triples, you should have been able to do 16 squared plus x squared equals 34 squared. If you're getting these wrong, this is about as easy as going to get on the test. All right, that being said, let's go over some homework questions real quick. I'm going to go over the ones that I saw. And just so you know, just having a blank thing saying I didn't know how to do it isn't good enough at this stage. We went through every single lesson. So numbers 17 and 18 were both very, very doable, and they're very doable questions that will be on the test. There will be several of those on the test that look just like that. So I'm just going to start going over one of them. I'm not going to finish it. If you need help on those, come see me outside of class. So if you didn't do 17, 18 at all, and you just have blanks there saying you had questions on it, that means I took off points off your homework. Except for Tyler, you weren't here to ask questions or anything like that, so I'll give you an extra. What you need to do is you need to finish those and show them to me to get those points back. But the first ones I do want to go over, these I will not take points off for because these are a whole new concept, are 20 and 21. I'm just going to do one of them. So 20. I'm looking at that 150 degrees. Well, this whole circle is 180 degrees, so that makes this angle 30 degrees. Which means if I do like we did in our homework, I would just drop that down to create a 90-degree angle. So that triangle right there that I created is a 30-degree, 60, 90-degree triangle. And I said any line that connects to the circle is a radius, and the radius is always 1. So this hypotenuse is 1. Now with 30, 60, 90, we go ahead and mark it with some variables. I'm just going to pick S. So the side across from 30 is S. The side across from 60 is S square root of 3. And the one across from the 90 is just 2S. So I'm looking at 2S pointing to that 1. That means that 2S equals 1. Which means if I divide both sides by 2, we have S equals 1/2. Well, that would mean our S square root of 3, replacing that S with a 1/2 would be 1/2 times square root of 3, which would be probably nicer to write as square root of 3 over 2. Yeah, sorry. The hypotenuse is always going to be 1 because we said this is a circle with radius 1. So that means any line you draw here is a radius. They're all going to be 1. So this is going to be length 1 as well. All right, so we have this height here is S, so that's 1/2. But here's where I'm going to change something a little bit. We're on the xy plane, and we said yesterday in order to go this direction on the x-axis, you have to go in the negative direction. So instead of a positive square root of 3 over 2, I'm looking at that as being a negative square root of 3 over 2. Meaning that the point F, that point right there, is actually negative square root of 3 over 2 and up 1/2. All right, so it's just a 30, 60, 90 triangle, and you're going to find that it's pretty much the same thing on that last one. The other one I'm going to just start going over because you are expected to know how to do these is number 17. Number 17 is a whole bunch of triangles. This will show up on the test. You have to know how to do these. So I'm looking at the only measure that I know, and that's that 30 degrees. Since that's 30 degrees, that makes this guy a 60 degrees. All right, so that becomes a 30, 60, 90 triangle. So we now have a 30, 60, 90 triangle. So with that 30, 60, 90 triangle, we would just label it as the one across from our 60 degrees is our S square root of 3. The one across from that is our S. And then we'll have our W is just going to be 2S. Well, if S square root of 3 equals 10 square root of 3, you better believe your S is just 10. So that S equals 10, which makes our W 2 times 10, which would be 20. Well, our next triangle I'm looking at is this red one I'm copying in here, but I know the hypotenuse, I know the base. So actually that's going to be a Pythagorean triple. That's 4 can go into both of those, so that would be a 4, 5, a 3, 4, 5. So it would just be 3 times 4, so that x would be 12, and that would get your y. You are fully expected to be able to do these. It is just pulling out triangles that are 60, 30, 90, and then recognizing that you know the hypotenuse and you know the base of it, which gets you this one, whether you know Pythagorean triples or not. X squared plus 16 squared equals 20 squared. That will get you your x. Now you have whatever this is squared plus this squared equals 13 squared. And that's the exact same thing on 18. So if you did not have those done, if you just had blank things and just a question mark by it, you do have to show me that you can do it to get those points for those, because those are important that you know how to do those, and that's why you get points for those. All right, any questions on those? Okay, so you have to show me those to get those points back. Other questions on any other problem that was on the... Yes? Number 16. Ooh, I'm on the wrong thing. That's wrong. Got rid of that guy. All right, number 16. Number 16 was this guy. And what I'm going to notice, first of all, is that 60 degrees up in that top right. And since it's 90, this has to be 30 degrees, right? The next thing I'm going to look at is, well, that doesn't help me much because it's a 30, 60, 90, but I don't have any values there. I just have a P and a Q. So that means I have to look at this triangle down here. Well, if we look at that triangle down there, we have two sides that are congruent. If our two sides, if we ever have an isosceles triangle that's a right, we have 90, so we have 180 minus 90. We have 90 to distribute between those two, so each one is 45 degrees. So that's a 45 degree, 45 degree. Which means both of these are S's, right? That's an S, and this is going to be S square root of 2. So since it's S squared root of 2, you're basically going to do 6 squared root of 2 times square root of 2. Is that, can you picture that? Yeah. Okay. Are you good from there, or do you want me? Okay. Other questions from the homework? Questions going once? I'm going twice? Sold. All right, we are going back to 8.1. Woo! It's a full circle. We started with 8.1, we're going back to 8.1. We're going to learn kind of a nicer way to solve right triangles with an altitude. We've already done this when we did similar triangles, and you're going to see that's how we're going to set it up at first, but there's a much easier method if you remember. All right, recall that the portion in an equation in which two ratios are equal to each other, we solve proportions by using cross multiplication. In other words, our extremes means. So a geometric mean, if I ever say find the geometric mean, which I'm not going to ask that very often at all. In fact, I don't think I ever put it on a test or anything like that, but you should kind of know it. It's when the means of a proportion are the same. And I'll say what that means in just a second. That the number is called the geometric mean of the two extremes. The two numbers are not the same. So that means, if we look down here, if I ask you to find the geometric mean between 8 and 10, I'm looking for that number that would be the exact same mean between these two. Basically, that scale factor that these are the same. So you're just looking for these two being the exact same number. So if I ask for the geometric mean, you just take the first number and put it as an extreme, and the last number as an extreme, and you put the same variable for these two. And then you just solve it. So that means we're going to use that cross multiplication. Cross multiplication, we're going to get that x squared is going to equal 80. So that means that x is going to equal square root of 80. But that is definitely not simplified, because 16 goes into 80. 16 goes into 85 times, which is going to equal 4 square root of 5. On the next one, I'm supposed to find a geometric mean between 9 and 12. So we set it right just like that, where we have a 9 and 12 on our two extremes. And we're looking for that number that fits on as our means being the exact same. So in this case, we're going to use that cross multiplication to give me x squared is going to equal that 9 times 12, which is 108. I'll take the square root of both sides to come up with x equals the square root of 108. That is not simplified. It turns out 36 goes into it, right? Yeah. So 36 goes into it 3 times. So that's going to equal the square root of 36 times the square root of 3, which is going to equal 6 square root of 3. Do you see how this is kind of tucked away in here? It's not on your homework. It's not on your test. It's just something that can show up, but usually doesn't. All right, so I do have to cover it, but I don't find this as being a very big idea in class. Not even big enough to put on homework. It's not actually on the homework there. It's not on your test. So we just went over what the geometric mean is. And the reason why we're going to have geometric mean is because we're going to use it, but we're going to use it in a way that makes it very simple to understand what you're doing. All right, so first of all, the difficult way of solving sides of a right triangle with an altitude. So this whole lesson is basically going to be on right triangles with altitudes. This only works for right triangles with altitudes. Once again, this only works for right triangles with altitudes. That being said, a couple of you are going to apply it to other things, but it's only for right triangles with an altitude. That means you have a right triangle and you drop an altitude. Well, if you have a right triangle and you drop an altitude, you actually create 3 similar triangles. Those 3 similar triangles are the big one, that ADC, and that CDB. That will always happen if you are dropping an altitude on a right triangle. It always creates 3 similar triangles. When we first learned about this, I always told you with similar triangles, write them the exact same way. Write them with your 90 degree in the exact same place. So this works really well for similar triangles. So in this case, 3 statements we can write based upon these triangles is the fact that triangle ACB is similar to triangle ADC. We also know that triangle ACB is similar to that last triangle, which is triangle CDB. And finally, we have triangle CDB is similar to triangle ADC. So that means every one of those parts follows a ratio, i.e. if I did AC over AD, that would be equal to CB over DC. Or if we did AB over AC, that'd be the same thing as CD over DC. So that's what we did with similar triangles. I don't think we're going to finish this one. We're just going to set it up like we would if I was solving a similar triangle. Let me put this in a new slide. There's not enough room there. All right, it says identify the similar triangles, then find the value of x. So the first thing we're going to do is we are going to draw 3 similar triangles. The first triangle I'm going to draw is the big triangle. So I'm going to draw kind of that big triangle where the right angle is G, and that makes this E, and that's F. I also know this length is 5, I know this is 4, and I know this is 3. All right, I'm going to draw the exact same shape, but smaller. So the exact same shape, just a little smaller. And I'm going to pick, I don't know, let's pick this GHF. That's what we're going to write on there. So if you look at that triangle GHF, you're going to locate your 90 degrees. Your 90 degrees is your H value. So you're going to make sure to label this H. All right, now you have to use a little bit of logic. So this is longer than this side, so we're going to pick the longer side, which would be that HF. So F is going to be my far right, which would make this top one G. Now we're going to draw that last similar triangle, which is the smallest of the bunch. So we'll draw a right triangle that's small, but in the exact same order. Now we're looking at this EHG. Well, H is also my 90 degrees, so that should go there as well. H should be easy to write. Is that right there? All right, then we're going to have G off to the side here, and we are going to have E up here. All right, now let's go back. I labeled the first triangle as 3, 4, 5. That's a Pythagorean triple. For GHF, let's put what information we know. Well, we know G to H is X. We don't know the distance from H to F because we know E to F, but I don't know H to F. But I do know G to F is 4. Same thing with EHG. EHG, I know E to G is 5. I know H to G is X. And that's about all the information I have. So I guess we can go ahead and finish this one off. Yeah. Did I mess something up? E to... Oh, E to G is 3. I just misread it. I just had it zoomed out. You are correct. Yeah, that should be 3. Yes, you're 100%. E to G is 3. I just didn't have it zoomed there. All right, now we're going to use similar triangles if you remember that. Similar triangles are basically this 3, this X, and whatever was here would be similar. Then maybe this 5, this 4, I'll put a little triangle on it, and this 3 would all be parts of our ratio. Well, that means we can actually finish this answer. I don't even have to look at 4. I can just say, well, 3 over X is going to equal 5 over 4 because they are a ratio. That is similar triangles. That is what we did. If we solve this using means and extremes, we're going to come up with 5 times x is 5x equals 3 times 4, which is 12. So x will just equal 12 over 5. Not the most fun thing in the world to do, is it? To have to separate those into 3 triangles, find stuff that's similar, remember our similar triangle, and then find a ratio. So an easier method, whoa, all that stuff stay on there. That is a glitch in the matrix. All right, we're going to have a shortcut to finding the geometric mean. That is basically what we found on the other one is our geometric mean. The first method we're going to learn is called the heartbeat method. And it kind of looks like a heartbeat. Once again, this only works for altitudes of right triangles. So, with the heartbeat method, we're actually going to draw a picture on top of our triangle to figure out what our pattern is. So our step 1 is we are going to draw a line from A to D. And it's going to look a little something like this. I'm going to, what color might stand out? Green, maybe? I'm going to kind of draw across here. I'm going to end about there. Not all the way to D, but just partway through D. Step 2 is I'm going to draw a line from D to C. This is where it kind of starts looking like a heartbeat. So now I'm going to go, oh, I was using green. So now I'm going to go up. I'm going to make those a little thicker. So we went from A to D-ish, then we go up. Then we go back down. We go from C to D. So we come back down. And then finally we go from D to B. See how it's kind of like a heartbeat? That little boop, boop. But what does any of that mean? We are just understanding segments that would work in similar triangles. So now we're going to, after the drawing, we're going to write the following proportions based upon our drawing. So our first drawing went from A to D, so we're going to write AD. Our next part was we went from D to C. So we're going to write either segment CD or DC. It's the same thing, so CD. That's going to equal, I come back down CD, so we're going to write CD. And finally, we go from D to B. And we go DB. So the heartbeat method, if I have a right triangle that has an altitude, I can just go A to D, over D to C, over D to C, over, I'm sorry, I said too many overs. A to D, over C to D, equals C to D, over D to B. That is called the heartbeat method. Those ratios hold. If you do the similar triangles, you come up with those exact same ratios. Now, sometimes this won't get me the information I need. And if it doesn't, then we're going to use the bunny ear method. You got to stretch your imagination on this one, being bunny ears, okay? So the first thing we're going to do is we're going to go from A to B. Once again, stretch your imagination and picture bunny ears. So I'm going to draw a start of a bunny ear, A to B. Now, following the same pattern we did in the last one, I'm going to write AB down here. The next thing we're going to do is we're going to go from B to C. So I'm going to come up here. And so we're going to be over either CB or BC. I'll just call it CB. Now we're going to come back down. We're going to go from C back down to B. This is where I have a bunny ear. Can we all see the bunny ear? Kind of. Stretch your imagination. Is right here. That's a bunny ear. And the last thing we're going to do is go from D to B. And it'd make more sense if we went all the way back to A, but you can kind of see the bunny ear you create. All right, let's finish that off. So the other side would have been CB. And then we'd go from B to D. So we have a heartbeat method and we have a bunny ear method to find missing sides of a right triangle with an altitude. You do need to know these methods. All right, whether you remember the names, heartbeat and bunny ear, I don't care. It helps me remember them. But you do have to find these methods because it's going to make your life a world lot easier than having to draw similar triangles. Otherwise, you have to go back to your similar triangle section and relearn all that stuff for the test because we are going to have problems like this on there. All right, so let's see this in action. All right, our first one has a right triangle with an altitude. So in this case, what I'm going to try to do is I'm going to use the heartbeat method and see if it works. So the heartbeat method, I'm going to start from the left. I'm going to go up. I'm going to come back down. And I'm going to go over to Y. Now I'm going to redo that with red and talk about what I should be writing. So when I do that bottom line here, I'm going to write 12. Now as I go up, I'm going to write over 18. And that's going to equal, I come back down 18, so I'm going to write 18. And it's going to be over y. And you could have did it the opposite direction. You could have did y over 18 equals 18 over 12. Either one of those would have worked. So let's go through this one. So we use our means extremes to come up with 12y equals, correct me if I'm wrong, I got 324 out from 18 times 18. Does that match? Okay. Then we divide both sides by 12, and we end up with y just equaling 27 if you plug it all in and get it right. Does that match what you guys got? Cool. All right, number 6 is very similar. I'm looking for y. So if we kind of picture our heartbeat method, it would go 5 over y equals, and we come back down, y over 8. Yeah, sorry.
Is it always left to right?
No, it doesn't matter. I always go left to right because it's just kind of the way I read things. I read things left to right. But if you would have did 8 over y equals y over 5, you would have had the exact same thing. The only difference is the 8 and the 5 would have been switched places. But you come up with the exact same answer. Yeah, so it doesn't matter left, right, right, left. Whatever looks visually stunning to you, I guess. All right, so we're going to use our means extremes to go, okay, y squared equals 40. So we are going to have y equals the square root of 40. That is not simplified. 4 goes into 40 10 times, so it'd be square root of 4 times square root of 10, which equals 2 square root of 10. So your y equals square root 2 square root of 10. Any questions on the heartbeat method? That's what those two kind of are. We're good? Okay, let's go over to 5 and 7. Now, don't write the heartbeat method on this because I'm going to draw it on here and you're going to see it's not going to help you at all. So if I draw the heartbeat method, it would look like this, where I would have 16 over nothing equals nothing over nothing. That's not going to help me get these answers. So that's when we start looking at the bunny ear method. Well, the bunny ear method, don't write this down either, it can go in two different directions. Our first direction could look something like this, where I come up, come down, and over. Do we know all of those values that I just highlighted? No. So let's go the opposite direction. So I'm going to go across this way. That whole length is z, so I'll start with doing a z. And then it's over. Bunny ear comes up this side, which is length 27. And it comes back down that 27 as well. And finally ends up with this short section here, which is 16. So once again, I go all the way across, which is z. I come up 27, I go back down 27, and then I go across this little section, which is length 16. I do want to note, if you're doing this right, both of these numbers better be the same. Your means better be the same, at 27 and 27. All right, so now we just use means extremes or cross multiplication to come up with 16z is going to equal 27 times 27, which is 729. Whew. And then just for the sake of this problem, it might not always be that way. But we're just going to put a decimal. We're going to go z equals, not equals, but is about. Let's just round to the 10th place. I got 45.6. Does someone want to plug that in and make sure that number is correct? It's good? Awesome. All right, our next one. Is your X on the bottom, or is that just how it copied weird? It's on the bottom. Okay, we're going to put the x over on the right-hand side. I don't have a clue how that got changed. So we're actually put the x over here. Because on my copy, it's over there. Okay, so once again, this looks like a bunny ear method because I know that full length. So what really tells me I'm using the bunny ear versus the heartbeat. Bunny ear, you're going to notice you know this whole distance, this little distance, and I got something up here. You're going to know to use the heartbeat because your altitude has a length, or you're looking for something across the altitude. That's when you know to use the altitude one. So this one is another bunny ear one. So we're going to do 8 all the way across 8, so I'll put an 8. We're going to go up x and down x. So that means I'm going to have 8 over x equals x over, and just the little section, which is 2. Okay, using means extremes, we're going to do 2 times 8 and x times x. So we'll have x squared equals 16. We take the square root of both sides, and we'll have x equals 4. So once again, I took the square root of both sides, and we have x equals 4. For my money, isn't this a lot easier than pulling out those bunch of triangles? And yep. All right, last 2. So number 8 is kind of what you'd see like on a test or something that's a little more involved, because now I have 2 variables, and you have to solve them in a particular order. Let's go ahead and look at it out of order. Out of order would be this distance, up, down, and that. Because what you would have there is you'd have 16 plus x over y equals y over x. That's too many variables. You shouldn't have 2 variables in there most of the time. So let's try heartbeat and see if it makes it any easier. So my heartbeat method would be go across here, which would be 16. So we'd have 16 over, we'd go up 12. So we'd have 16 over 12 equals, we go back down 12, equals 12 over x. That seems a lot more manageable, doesn't it, than the other one? Because now we just use our cross multiplication. We're going to come up with a... Oh, that is weird. I got to redo this one. Okay, so we are going to have 16 times x, which would be 16x, equals 12 times 12, which is 144. I don't know why I had the wrong numbers on here. Let's see here. So x is going to equal 9. Is that what other people got? Awesome. So now we know this x value is, instead of x, we're going to put 9 in its place. So now when I do my bunny ear method, let's do bunny ear in green. We're going to go all the way across this, which is 9 plus 16, which would be 25. Now we're going to go up y, so it'd be over y, equals y, because we go back down y, and then we go over to that 9. So it's going to be y over 9. So then we're going to have y squared equals 25 times 9er, which is 225. And you come up with y equals 15. All right, we just have one more to go. Someone tell me which one I should use, bunny ear or heartbeat on this last one? Heartbeat. Awesome. So Sahej told me heartbeat. Can someone tell me what my first step is with heartbeat? Besides Sahej, because she came up with the method. I need someone else. So you should be working on it. You should be helping us. Yeah.
B plus 3 to...
Okay, b plus 3. So you said we're going to go from b plus 3. So we're going to write b plus 3. All right, someone new. Tell me what I'm going to do next. Sam. 6. So we're going to go up 6. The next one is the hardest part. What do I do next? Someone new. Lyth.
Go down 6.
I go down 6. And can someone tell me what my last number is? Megan? Across 8. Awesome. Over 8. Now the reason why I picked this one, because when we do our means extremes, don't forget, well, 6 times 6 is 36. But don't forget it's 8 times the quantity, b plus 3, equals 36. Don't forget about that. So we're going to have 8b plus 24 equals 36. Subtract 24 on both sides. You should come up with 8b equals 12. And so we're going to end up with b equaling 12 over 8. Right now, I'd look at the directions. If the directions say give me exact form, just leave it as a practice and reduce it. If it says to the nearest tenth, then just put it in tenth. I'm just going to reduce the fraction down to 3 over 2, and I'm going to leave it. It'll be based upon the directions on the exam, what it asks for. More than likely, I'll ask for just 3 over 2. All right? I like that better than having to plug it in a calculator and put a decimal down. That's the means extremes. That is our heartbeat. That is our bunny ear method. All right? You just have to remember them. Draw your pictures. Take your time to do it correctly. All right? Any questions for me? All right, today was our last lesson. Tomorrow we'll have time to work on a review packet. On Monday we'll do, scratch that. We might do the activity tomorrow and work on our packet tomorrow. Yeah, probably tomorrow we're going to do the activity. All right, guys, the rest of the time is for you to work and ask questions. The answer guide is already online.